Alrighty guys, welcome to day 8 of Advent to Code. About to start here again as always. Code is ready, all set up and good to go. Grab the inputs and then we will get started here in 5, 4, 3, 2, 1. Let's do this thing. This doesn't look fun. This kind of looks like a pain. Okay. You barely reach the safety of the cave when the whale smashes into the cave mouth, collapsing it. Sends to indicate another exit to this cave at the much greater depths, so you have no choice but to press on. As your submarine slowly makes its way through the cave system, you notice that 4-digit 7-segment display and your submarine are malfunctioning. They must have been damaged in the escape. You'll be in a lot of trouble without them, so you better figure out what's wrong. Each digit of the 7-segment display is rendered by turning on or off one of the 7 segments named A through F. So to render 1, only segments C and F would be turned on, the rest would be turned off. Render 7, yeah, okay. The problem is that the signal which controls the segments have been mixed up on each display. The submarine is still trying to display numbers by producing output from signal wires A through G, but those wires are connected to segments randomly. Worse, the wire segments are mixed up and separately for each 4-digit display. So they're all just kind of whatever. Okay. So you might know that only signal wires B and G are turned on, but that doesn't mean that segments B and G are turned on. Wait, so you might know that only signal wires B and G turned on, but that doesn't mean segments B and G turned on. Okay. The digit that uses 2 segments is 1, so that must mean that segments C and F are meant to be on. Okay. For each display, you watch the changing signals for a while and make a note of all 10 unique signal patterns you see, and then write down a single 4-digit value. Okay. Supposed input, for example, you see this, the entry is wrapped into lines, yep. Each entry consists of 10 unique signal patterns and a delimiter, and finally the 4-digit output value within an entry. Okay. The unique signal patterns correspond to the 10 different ways that the submarine tries to render the digits. Because 7 is the only digit that uses 3 segments, D, A, B. What? That means to render the 7 signals D, A, B are on because 4 is the only digit. Okay. Signal wires correspond to each of the 10 digits. Then you can decode the 4-digit value. I'm like sort of. Okay, for now, focus, you consider the large example. You should be able to tell which combination of signals correspond to those. So we just have to find 2, 3, 4, and 8 values. And they're always going to be after the delimiter. Okay. Okay, so for string, I guess that's what it's going for. Well, let's kind of see. Here is going to be our parts. It's going to equal s dot split on the delimiter. And then again, this is going to be the second half. And it's going to be then parts 1 split on the spaces here. So then we have to go through here and count up. Okay, so then we go for each string s, or for string s part, I don't know, I'm just kind of making these up now. We're just going to check if s part dot length is equal to, that's not, it's going to be 2, 3, 4, or okay, so if it equals 2, two, 3, 4, or what's this one? 7. We're going to need a count here, and we're just going to increment count, as that's all it's asking for. And then we're just going to lap count. Let's just run this. Let's just see if this happens to be right. 79, that seems kind of wrong. Yeah, okay. Oh, because it's grabbing his regex. Ha ha ha. I see. Can I split it on just, that's trying to regex it. That's why it's having issues. No, stop trying to regex. I see why it's having issues. No, just do it on, there we go. That's not doing it right. Okay, maybe to get it. 26, okay. So it is okay. Let's go back to the full input. Yeah, regex is weird with, okay, there we go. 245. All right, took for way too long, but whatever. Through a little deduction, you should now be able to determine the remaining digits. Consider again the first example above. For some careful analysis, the mapping between signal wires and segment only makes sense in the following configuration. I still don't understand. I'm still. What's the? Oh. For example above, the output value of each entry can be determined. Adding all the output values in this large example produces. Okay. So we have to take this, and using what we now know about mapping these, we have to figure out something. This problem isn't like sticking with my head. Like I'm not. Some. Okay, so we're doing both sides. So this is, so it's 1, 2, 3, 4, 5, 6, 7. So okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Why is there 10? 8 segments. I guess it's 10 digits and a 4-digit. Oh, because there's 10. Okay, I see. Right. Okay. So using these, we have to figure out how it is. So like A and B is a 1. Is it always going to be? But like then DAB. It's this mapping here that's getting from. But if we know which ones they are. So the only ones we don't fully. So 5, 2, and 3, and then 9, 6, and 0. Okay, so what we can do though. And then, so this part we're gonna need the first half. So the first half is what's gonna build up this. What we're also gonna do is we're gonna do a string array here. And this is going to be digits. And so we're going to go ahead and go through the first half, and then a switch on spart.length, and if it's 2, we can just go ahead and just throw into digits of what's a 1? Yeah, so digits of 1 is going to be equal to this. Go ahead, break out of this. And then 3, 4, and 7. 3, 4, and 7. 3 is 7. 4 is 4, coincidentally enough. And 7 is 8. Okay. Oh, no, it's supposed to be 10. That's weird. I must miss the 1. Okay, and so now we just need if there are 5. So case of 5 and 6, I guess, is all we need. So 5 and 6 we don't know because we need the rest of them. So how do we... So a 0 will not match 4. A 0 will be missing the segment in 4. Okay, so this isn't going to quite work. Because we need the other ones first. So we have to go through them first and figure it out. So to do this, okay, so we need first to figure out which one is the spart.length. Okay, now let's just do it this way first. How about that? So we'll do a dual for loop. The first one is just going over just the ones we care about, and the second one will be the kind of the rest of them, or the other logic beyond that. Okay, so here's our first for loop. Let me get rid of this right now. Here's our first for loop. Get rid of this. And then we'll do a second one here, only caring about 5 and 6. So for this one, we can do is if spart dot wait, so wait, which one's 5? 5 is sorry, this is 6. 6 logic first. Okay, so first go with the 0, so we'll do a for loop on digits 4, whoops. We need the two-char array. So if it's a 0, that means it has to have all of them. If it doesn't have one, it's not a 0. So if spart is there a if it contains C, or if it doesn't contain, if we go through the one to 4, it should have all but 1. This needs to be false. So we're looking for if it doesn't contain, so then 0 equals true. We're good there. Fine. String. Make my life harder. Okay. Add a break. Okay, and then we can just go ahead and check here. If it's the 0, then digits 0 is S part. Actually, we can just do it here. We don't even care about that there. Okay, so there's our 0 check. What are the other 6-digit ones? 9 and 6. So 9 and 6. 6 will not match 1. So we have to go through 1, and if it doesn't contain it, there. Otherwise, 9 is that. Right? Yeah, because you go through 1 will have it. So if it has both of them, it's 9. If it doesn't have one of them, it's 6. Okay. Now let's move this exact logic up to here, and we'll add the check for the other 3. The other 3 are 5, 2, and 3. So 3 will have both of 1s. 5 versus 3. 3 will match 7. Okay. I shouldn't. There's no point to. Actually, there's no point to copy this. So we'll do. This is the. What was it? The 5, 2, and 3. So what did I say? 3 is gonna match 7. So we have to go through all the digits 7. If any of them don't match, it's not 3. And so we can do if 3. Now we can do it. Which was this here. There's 3. So now we just have 5 and 2. 5 and 2. Oh no, how do we do? What numbers? 5 will match 6, 2 won't. Okay, so let's do 5 check. Do the exact same thing we just did with 3. Five will match. Let's do this. Okay, so 5, 5, 5. And then the last one is 2. So this should give us all of the numbers. This looks awful, but this should do it. And so now that we have this, we can now determine the digits, or the second half, we can determine what they are. So we go to the second half and we decode it. Okay, so then after this, S and second half, we can then just look up calls to find. So we're gonna do for string for int I equals 0 while I is less than 10, I plus plus. So we have to go through all of these, and we have to do a check here on if digits I equals to find. Then here's our number. So now we can do, actually it should be this. And we'll do number times 10 plus I, right? Because this is the actual, yeah. Oops. And then because the times 10 will also then shift them over to make sure you build up the number correctly. And then we just add them all up. And then we can just do here sum plus equals number. And YOLO. Let's see if this even works, if it crashes. No pointer. 4 should have been found. This is just, okay. Yeah, we want to be done here, but then we don't want to check this. Let's just make some methods here. So now we can use this is 0 check instead. Digits s part and then we could throw another check here for 6. So do the exact same thing. Yeah, this isn't pretty, but I guess I'll get there in the end. Sorry about the train going by. So I guess this actually isn't, this is a bit cleaner actually. It's gonna look a bit cleaner in the end, but I don't know how I feel about it. What's the next one? So we gotta go down to here now. So now we need the 3 check. So 3 check's a bit more complex. So this is 3 break, and then we can return 3. So it's a bit more complex, but it's nothing excessive, I guess. And then the exact same thing for 5. What can I? Thank you. And then here's the else if digits. Oops. Okay, let's see if this gives us any better results here. They gave us worse results? No. I don't believe it. So we got 0, 1, 2's missing, 3, 4, 2, 5, 6. Checking, wait. First half, is first half, oh, first half is still, okay. I'm also going to strip this. Like I should do these both. Okay, maybe now we'll be in better shape. Okay. That's looking better. Okay, hold on. I think I'm doing this wrong. We need to do 9 first. We should be doing a check for is 9, because 9 will match 4 entirely. Yeah, because 9 will match it entirely. Just like these will. So I'm just doing my logic wrong. It's just, yeah, my logic is just being done wrong. So 9 and 0. 9 matches entirely, the other two don't. So that's how we know it's a 9. And then from 6 or 0, we know it's a 0. So change is 6 to 0. We know it's a 0 if it matches 1 entirely. Okay, I just went about doing this wrong. We're just going to change this to instead be 1. Okay, I think we have this one. Is 5. Okay, so we didn't get 6 though. That's also not 4 either. Did I mess up 4? Is 4 what's going wrong? Wait. 4 has 4 parts. So how is 6 null? That's a 6. So many typos, so many errors, so bad. Now we only have 1. 0, 1, 2, 3, 4, 5. So 5's the only one that's wrong. Okay. We're getting there. We're getting there. Is this logic all correct? Let's just make sure this. So 3. So what's the check for 3? Yeah, check for 3 is that matches 1, right? Yeah. Oh, okay. It should be 1, not 7. Either 7 and 1 should both be the same. Okay. That's fine. So that's 3, and then we go for 5 or 2. 5 or 2. 6 has 1, 2, 3, 4, 5, 6. Okay, yeah. So yeah, so then it does. Okay, so 5 is inside 6. But it's the other way around. It's 5 contains. No, it's not that way. 5 contains all but 1 of 6. 2 is all but 2. Okay. Let's do this then. Since 2 misses 2, let's grab this. And if it doesn't contain, we just do missing plus plus. And return missing equals 1. That's 5, not 2. That should solve it, right? Thank goodness. Is this my input or is which? That's not the sum though. Okay, so that gave me all the digits. It doesn't find it. Oh, they're permutation. Okay. Really? They're gonna be like that? Well, then how? Okay. Let me Google this real quick. There's a quick way to sort a string alphabetically. Okay. So let's do this. So we have digits, so let's go back through digits. So for let's just go back through and sort. There's an issue with the digits not being sorted. Apparently they gotta be sorted. Oops, I'm missing I, that's why. So this is gonna be digits I to char array, and then we can do digits I is going to equal to new string arrays sort to sort. Whoops. What? Oh, it sorts. Okay, I see. It doesn't. It sorts and keeps it there. Okay. Okay, so I have to do that, and then let's set it to find. We want sorted. Maybe. Let's see now. Please. We're done. We're done. Oh my god, that nightmare is over. Oh. My brain is just like fried, and it could not process that problem. I could not process this. Holy, that was bad. I just, for whatever reason, couldn't process anything. I don't know why. That was way worse than it should have been. But alright. Let me clean the code up again. Hopefully I can make this look somewhat manageable. Clean it up, and then I'll explain my solution here. Okay, so my brain's still just not processing things correctly. I don't know what's going on. But I cleaned it up as well as I can. I'm kind of just calling this day just a disaster and just taking my loss on this one. But at any rate, today's problem is that we have a 7 segment display, but we don't know the wires that go to each segment. They're all kind of messed up, and we got to figure out what wire goes to what and what the numbers are. Yeah, so part 1 here is basically going to go through these numbers here. This is the actual the actual output. We got to figure out what how many times we get a 1, I just closed the problem. How many times do we get a 1, a 4, an 8, or a 7? The reason why we need to find those is because those are distinct in that they have a certain amount of segments that only they have. So a 1 has 2 segments, the only number has 2 segments. 7 has 3 segments, the only number has 3 segments. 4 and 4, 8 and 7, the only ones that have those amount of segments are used. So we are easily able to calculate those because we can just go off of the length of the number of segments that are given here. So like here's a 7, here's a 1, so on. So that's part 1, pretty straightforward, nothing too bad. Part 2, though, is a whole other story. We actually have to, using those kind of known values here, we have to figure out the rest of them. So for the first part here, I went through and again gathered up those known values. So the first for loop here is just grabbing those 4 known values and dumping into digits. Our digits are just going to be storing the digits in like the string form of that digit for the segments just in its place. So 0 index is 0, 1 index is 1, so on and so forth. So we just find the 1, the 7, the 4, and the 8, and we go with that. The second for loop now is for finding ones that are of length 6 for the segments. So this is going to be 9, 0, and 6. They all have 6 segments, and we can just use some deductive logic to know which one's which. So for the 9, we need to know whether or not it matches the 4 digit. 0 and 6 do not match number 4, whereas the number 6 will have all of, it will match, or yeah, the 9 will match all of the segments of a 4. So we can go with that. And then because now that we have the 6 done, determining the 0 from the 6, well, that's pretty easy. We now just match the 1 because the 6 will not match a 1, whereas the 0 will. It will contain the same segments. So that's how we do the 0, then everything else, or whatever digits left, we would assign to 6. Same thing goes for the other 2 or the other 3. They use the 5 segments, so 3, 5, and 2. We use that same deductive reasoning. I think for 3, we do number 1, because 5 and 2 don't share the same segments as 1 that 3 does. And then for 5, we have to get creative with this one. We use the number 6, we use the segments from 6. The number 5 will have all but 1 segment being the same, but the 2 on the other hand will have all but 2 be the same. So we can just determine whether or not it's a 5 by if it's missing 1 or 2 segments in there. And then from that, now we have all the digits correct, but apparently the digits ordering is all messed up. So we just go ahead and just make it easy. We just order the strings that represent the digits in the segments. And then from there, we can go through the process of now ordering the string, figuring out the numbers correct, finding the actual digit for the sorted. So given the second part here, going through figuring out which digit these segments correspond to. And then from that, we can do some simple math to, because it's the first number, we can take the number, multiply by 10, add this on, and I'll keep shifting it left. That's what it is. This day has just been not good for me, so sorry, I apologize for the quality of these videos. We're not the best, but there we go. Day 8's done. I'll see you for day 9. I'm getting out here. I'll see you later. Peace out.